Okay, here I'm going to take you through solving the homework problem 8.2.17. Several people have had questions and problems here, so I've gone through and worked through it for you for a sample problem so you can use it as a guide for solving your own homeworks. Now, here we're being asked to determine a p-value and a critical value, and we're given the information of knowing what our alpha is. We're given our value for our z-value, and we are told we're a test statistic, and then we're told that we're testing the particular claim here. In this instance, it's p is greater than 0.90, and this is our alternative hypothesis. So this is what we're working with in this particular problem. So you will obviously in your problem be given a different alphas, different z-values, and you may be given a different alternative hypothesis. But I'm going to work through this problem with these examples, and then you should be able to use this as a template to help you solve your problems yourselves depending upon the unique values that you have. So the first step we need to do in solving these problems is determining the type of problem we have. If we have a two-tail, a left tail, or a right tail. Looking at your figures in your text on page 382 and 383 are also the ones that are posted on Blackboard. You can identify based on the symbol in the testing hypothesis claim, the alternative hypothesis, what type of tail test we are working with. So in this particular example, we have a greater than symbol, and that indicates that we are solving for a right tail test. So we need that information before we can proceed any further in finding either the p-value or the critical value, as our approach for finding those values is going to be different if we have a right tail, a left tail, or a two-tail. Okay, so our next step is following the flowchart down on page 383. We see that the p-value is going to correspond with the area to the right of the test statistic. All right, so we're going to locate our area for our test statistic here. So you use your test statistic to find your p-value. Okay, so you use your test statistic to find your p-value. So I think that's where all the people are getting confused is which numbers you're using to find which values. So you're using your test statistic to find your p-value. Okay, and then we're going to come back and you're going to find that you're going to use your alpha to find your critical value. Okay, so the testing claim tells us what type of tail test we have, a two-tail, a left tail, or a right tail. The z-value, the test statistic that we get, is going to be used to locate the p-value, and the alpha is going to be used to locate the critical value. So here we go. We're going to locate the area for our test statistic. Here we have z equals 1.59 for this particular problem. So it corresponds with the probability area of 0.9441. So there again, I'm taking my z distribution table, locating 1.5, and then coming over on the left-hand side, and then coming across that till I get under 0.09, and that gives me my probability area of 0.9441. However, I'm solving for the area to the right, and the z-table sums from the left. So I've got to take 1 minus 0.9441 to get my value, my final p-value of 0.0559. Now, pay attention, here's where it's really important. If you're solving for a left tail, the steps are going to be different. If you're solving for a two-tail, the steps are going to be different. So you need to make sure you're following that flow chart to know how to employ the area that you find that's associated with a particular test statistic. Okay? So if you need to take that, go through that again. And then once you've got this set, move on to the next one, and we're going to look at finding the critical value. So using the critical value, we're going to use our alpha to locate our critical value. So we're looking for the z-value that separates the 0.05 area to the right of the distribution from all the rest of the distribution. So again, we're looking for the area to the right, but the z-table sums from the left. So we're going to take 1 minus 0.05, which gives us 0.95. Okay, because if we have 0.05 to the right of our cutoff value, then everything to the left of it is going to be 0.95. So we're going to take that 0.95 and we're going to locate it in the body of the table and then identify the corresponding z-value. And in this case, the critical value z-value is 1.645. Now, in solving these problems, also make sure you're paying attention to the specific directions they're asking you for rounding for each of the values before you enter them. Looking at some people's work, that's apparently where you're making the mistake. So I hope this is very helpful. Let me know if you all have any further questions.